In this module, we'll talk about the process of adapting the application to look good on tablets and desktops. By default, apps work as is in those form factors, but this can produce a situation where an app feels like a scaled up phone app. Case in point, if we run the current app on a tablet, it looks horrible. It just doesn't fit. The images look bad and overscaled. The side menu and elements positioning doesn't make use of the available space. This is how the app looks after the changes we will review today. The icons in the layout look great. The side menu is permanent and doesn't change as we move through the elements. The app feels more like an app that was designed for tablets and can work reasonably well on a desktop. When we switch to other entries, such as the details entry, the form doesn't change, only the content in the center. You will notice that instead of using commands in the title area, we use large and convenient buttons at the bottom, which is possible now since we have more screen real estate. This is the key. With a regular app, every entry is a form, and with a tablet app, that doesn't work as nicely. Although it is possible to do so, it's often not the best approach. Usually, for tablet apps, we like having one form and replacing the content within. To achieve this, we derive a common base class instead of form. To implement that, I just looked at everything that failed when I switched the base class and re-implemented this in an abstraction class. The implementation for form is pretty straightforward as a result. Going to the base navigation form, the changes here are instantly familiar. We now derive from UI abstraction instead of form. Let's open up UI abstraction and see what we have there. UI abstraction opens with an inner class representing the form delegate. This is effectively the class that implements the standard form-based navigation. Naturally, it does derive from form, as all the calls apply to it. So instead of inheritance, we now have a form of composition. The constructor for UI abstraction accepts the title and layout, which are both passed onwards to the form in the default behavior. We don't need the full set of form constructors in this case. This is a special callback that subclasses can override. Since many forms have an OK cancel pair of buttons, I generalize that code, so if a UI abstraction subclass overrides this method to return true, we add an OK or cancel. This allows us to have toolbar commands in regular forms and OK cancel buttons in tablet mode. We implement this in the form in a very generic way. We just add a command and implicitly show the previous form. We have an onBack callback that allows the subclass of the UI abstraction to intercept this behavior and bind logic to the cancel operation. OK is identical with two small differences. The first is the fact that onOK is invoked instead of onBack. The second is that we keep a reference to the OK button. We need that for the validation code, so validators can still disable the OK button if the input is valid. Scrolling down a bit, we can see several methods of form that we overrode to provide sensible toolbar behavior in all cases. If you look at the existing forms before this change, you will see most of the forms already had similar code within them.